Alright, hey guys. So what I've done here is what I was saying I'd do in the first video. So what I've done is use the second shift register and run the cables. Just basically I've bridged the two shift registers so you can run 16 LEDs. Now in order to do this, instead of sending a single bit to one register to light an LED, I'm sending that same bit, but I'm splitting it in two. So it splits the bit and sends it over two signals. So you get this sort of loop array pattern. The problem with this though is that because it splits the byte, it splits the current, which in turn makes the LED dull. Now, I know there'll be a better way to do it. I haven't quite got that far yet, but I'm pretty happy with where we've gone. I basically use the old breadboard just as a power and grounding device, mainly because the digital output pins tend to fit in better to that than straight onto the Arduino. So what I'm going to do next is run 3 shift registers. So I'm going to use this breadboard and run the third shift register and another 8 LEDs and see if that splitting the bit in 3 will work. I don't think it will, but never doubt myself. So as you can see, we've got this sort of a loop sort of thing going on, which is pretty cool. I'll show you another program I wrote, which here's the code for it. I'll show you that later. This one? I think it's this one. Sorry about the video. Can't look through it. I think it's this one. Alright. Yeah, this is the other one. Let me just adjust the delay on it because it's a bit crappy. Too high of a delay. I just used a delay at 1000 arbitrarily. But let me just fix that. Alright. So here's another one I did. Bit of a UFO thing going on. I might use this method of coding instead, as opposed to splitting the 2 bytes over the shift registers. I might use this method. Basically, I've used binary to program the shift registers. It's a lot easier, to make sure you get that consistency. But again, what the difference is here is, as opposed to splitting the bits, it's just sending 2 bits to the shift register and splitting the 2 bits, so 1 per register, to light up 2 different LEDs. So you get, a single. But the only way, so you can get this sort of a look, the only way I could get it to do that though is by using opposite registers, opposite outputs. When I tried to loop it so it went 1 to 8, so 1 through 16, it didn't work. But when I did it like this, it worked. So a bit more tinkering, and I should get that fluid line, that fluid movement that we're after. But that's the brightness we want, because we'll diffuse it with a bit of opal perspex or something like that, or some acrylic spray painted. So this will sit under it, and then you just get that really nice movement. We're thinking you might diffuse it with some sort of a green or a red coloured cellophane or something like that, so you get rid of this bright white sort of light that we're getting from here. So yeah, this is where we're at now. With a bit more tinkering with the code, I should be in a good place to be able to start wiring it manually to the perf board, and I'll show you here. So this is our perf board. And this is the configuration we're going to have for the for the shift registers. So this side here, show you. This side here is the output pins to run, say, our LEDs, and here is our data inputs and our power supply and our ground cables. So the reason I've run them staggered like this is because we're going to have 8 resistors, or 7 on one side and 1 on the other, and plus obviously the soldering. So if we were to put them directly like side by side like that, we would find that it would be very confusing, and well, as if this isn't confusing enough. I believe that when it comes to soldering, it'll be a lot more difficult. At least this way we know that each side we're at here will know that these sides here will be outputs for the LEDs, and this will be outputs, 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 and then outputs, 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 etc., etc. So they're the 96 bloody resistors that we're going to solder on here. It's a lot easier to solder them to this perf board as opposed to in line with the LEDs. That just makes life really difficult for us. So yeah, what I'm going to do is bridge these panels here for the power and bridge those panels for our ground cable, and then as you can see the pins sort of protruding through, that's where we'll solder to it. And these have got individual copper sort of lugs, I don't know what the word for it is, so they don't, each pin doesn't interfere with the next. A bit more soldering, but it gets the result we need. So yeah, this is where we're at the moment with our little UFO thing. Like I said, I'll adjust the code a bit to try and get that fluid movement going on. But this is just to show you that we can bridge, you know, 2 shift registers with still only using 3 digital outputs from the Arduino. So I think we're in a good place now to, like I said before, to start moving on and building it. So I'll, once I figure out how to, fix that code up, I'll post it back up. Alright guys, see ya.